Okay, so we are now in the explanation of exercise 5. In the photocopies, we pass from third exercise to the fifth exercise. Okay, so I wrote here the different, because we went through oxides, that is this one, oxides, hydrides, oxides, hydride, oxide, hydrides, oxides, oxides. This is a salt because we have two different elements combined that are not hydrogen or oxygen. This is hydride, salt, hydride. This is two elements, sodium and fluoride. Fluoride together is a salt. This is oxide, hydrate and nitrate. Yes, because these two have hydrogen. We're going to solve the oxygen ones, the oxides. They finish all of them with ide. Go to this and this one, yeah. This is hydride 2. Good. Iron 2, and oxygen 2. We will write here, and 2 divided by 2 is 1, and we don't write 1, yes? Okay. So these oxidation numbers are 2 and 2, but we don't need them. In the next oxide, we have iron 3 is written already here, and oxygen 2 with Swift, and we have as a result this this compound. Okay, I will erase it too to make it clear. Yeah, good. Next will be calcium hydride. Calcium in this case has 4. No, sorry, 2. Okay, we went through the oxides first. Calcium in this case 2 and oxygen 2 is the same example as this one, 2 and 2. Then we divided 2 and 2. We divided by 2 is we get 1, and 1 we don't write it. Okay, good. The potassium dioxide, I had a mistake because it's possible to have this substance, the potassium dioxide, but we don't call it dioxide, we call it peroxide. Okay, peroxide. So in this case, I'm going to erase this. Okay, we don't need this D. Okay, and that's it. We have the potassium oxide. Potassium has an oxidation number, because it's in the first column, it's an oxidation number of 1, and an oxygen has an oxidation number of 2. Okay, so this 2 goes to the potassium, and this one goes here. We don't write it. Okay, oxides, we have gold 3, an oxygen with 2 oxidation number, with Swift, and we obtain this, and that's it. We are going to finish with hydrides. Hydrides, of course, all the other hydrogens has 1, and barium. Okay, barium. We need to remember that the oxidation numbers of some of the elements. Barium is in the second column, so it's 2. Okay, is earth alkali. So we Swift. We don't write here the 1. We don't need them. The 1 we don't write it. Disappears. Okay. Next, calcium again. is a 2 and hydrogen 1. So again, we don't write the 1, but we write the 2 from the calcium here. Hydrosulfuric acid. Check this out, because this hydro goes first. Yes, like in here, hydro first with this one. Hydraulic, hydro first. Yes, hydrogen sulfide first. Okay, selenide, hydrogen, selenide, first hydrogen. Okay, hydrosulfuric. As you know, hydrogen has 1, sulfur has 2, among others, like 8 or 6. But in this case, we need to simplify as much as possible. The lowest oxidation number. So we don't write the 1 from the hydrogen, but the 2 we put it here. Okay, hydrosulfuric acid. Okay, this salt iron, I'm going to explain it, but I'm not going to ask it. Okay, so be relaxed about that. Yes. So with another color, like for example blue. So iron 3 as an oxidation number, and sulfur in this case has 2. Like in here, we're going to use the most common oxidation number of sulfur is 2. Okay, so with Swift, these 3 goes to the sulfur, and these 2 from oxidation number of sulfur goes close to the iron. As simple as that. Yes. Borane. This is a commercial name that we need to remember by heart. Yes, borane. We don't have any other examples of commercial names. Okay, so that's no problem. Is BH3? Yeah, BH3, BH3. So it will be boron hydrate, trihydrate, boron trihydrate. Okay, boron trihydrate. And systematic, we don't have the systematic, we have the commercial name. Yes. Good. Hydrogen sulfide, and hydrogen first, sulfide second. Again, here oxidation number 1, sulfur oxidation 2. We put it here, the 2, but we don't write here the 1 from hydrogen. Lithium sulfide, the oxidation number of lithium, sodium, potassium, rubidium, cesium, francium, the first column. Alkali, they only have +1, and sulfur has 2. Sorry. So we Swift, and that's it. But this is a salt, I'm not going to ask it. Okay. Hydrochloric acid. Hydro. First of all, hydrogen, and then chloric. Yes. Chlorine. Chlorine has an oxidation number of 1 in this case. Good. 1, 1. We don't write it. Carbon tetrahydrate. Carbon has an oxidation number of 4, and hydrogen 1. Yes, so this will be the result. CH4. Hydrogen selenide. Hydrogen is 1, selenide is 2. We Swift, and that's it. This is another salt, sodium fluoride. Sodium is +1 and fluoride -1. So 1, 1, it stays like that, but I'm not going to ask it, okay? Gold 3 oxide, gold 3 as you can see here. And yes, we solved it before. Hydrochloric acid, yes. Tellurium. Tellurium is 2, hydrogen 1 with Swift. Barium. Barium is, in this case, is 2 and hydrogen is 1. So we Swift and we obtain this formula, barium hydride. Yeah, good. Barium is in the second column. Alkali, earth alkali, all of them have 2 as an only oxidation number. We finish with the exercises with this chart. You had this column and you have to put the 2 names, stock and systematic, of these elements of the first column. Okay, barium monoxide in the stock, barium oxide. Why we don't write in brackets the barium has oxidation number of 2? Because it's the only oxidation number that barium can have. Earth alkali, yes, okay. Nitrogen trihydride, good, yes. Nitrogen and 3 hydrogens, and the commercial name is ammonia. In this case, hydrogen telluride, okay, yes, like that, hydrogen telluride. Why we don't write dihydrogen telluride? Because it's the only hydrate possible. Okay, so this by heart, yes, and this is the acid, hydrotelluric acid. Carbon dioxide, carbon with the oxidation number of 4, oxide. Lithium oxide, as you know, is lithium in the first column. Alkali, all of them have +1 oxidation number, 1, and an oxygen has 2 with Swift. And lithium oxide, why we don't write oxidation numbers in brackets here in the systematic? Because lithium only has +1 as an oxidation number, the same as oxygen. Hydrogen fluoride, yes, good. And hydrofluoric acid, okay, hydrofluoric acid, yes. We don't write in these examples of acids, we don't write the oxidation numbers in brackets. All the acids, we don't write them. We don't write the oxidation numbers here. We don't write the oxidation numbers in Roman names like in here or here or here in the oxides. Yes, but these ones in a specific group 16 and 17. Yes, group 16 and 17. Tellurium is from group 16. Yeah. Fluorine is from group 17. That's why it's an acid. Chlorine is group 17. Selenium group 16. Yeah, that's the weird ones. Okay, good. Carbon monoxide. In this case, carbon has oxidation number of 2. We write it down. Okay. Yes, because this is like having a 2 and 2, and then we divide it by 2. Okay. Calcium oxide. Calcium oxide, as you can see here, calcium um, is in the second column, earth alkali, all of them plus 2, and oxide minus 2. We will have a 2 and a 2, but we don't write it because we divided by 2. Sorry, like in here, 2. So at the end, in these two cases or scenarios, we don't write it. Yeah, good. Okay, as I said, hydrogen chloride, hydrogen selenide, the hydrates from these two groups, 16 and 17, are very specific. They are acids in aqueous solutions. Gold trihydrate, yes, gold, and then 3 hydrogens. Gold in this case has oxidation number of 3. Yes, oxidation number of 3. Nitrogen trihydrate, yes, 3-hydrate, yes, because in this case nitrogen has an oxidation number of 3. Yeah, good. This is a commercial name. Yeah, a commercial name of ammonia. Yeah, a commercial name. NH3, and is in group 7, group 6, group 15. Okay, good. Silicon dioxide, and in this case silicon has an oxidation number of 4. Yeah, could be 8 or 4 or 2, but in this case it's 4. Yes, so why can we write silicium dioxide? Because it comes from the other compound, silicium oxide, but in this case is a 4 and a 2, and what happens, we divide it by 2. Yes, 2 between 2 is 1, we don't write it. 1, we don't write it, and then 4 between 2 is 2. So it's what we have here. Yeah, and dinitrogen pentaoxide, nitrogen can have 2 oxidation numbers. Oxidation number of this nitrogen is, in this case, 3 oxidation number. 3, and in this case 5. 3 and 5. That's it. Okay. So this is are the solutions of the exercises. I hope you understood and followed all the explanation. The key thing is to remember the oxidation numbers, but the key thing is also, oh sorry, I thought it was um, the key thing. I'm going to also upload this screen. So the key thing is to remember the that stock is more informative name than systematic, okay? Because they are telling me, for like in this example, how many atoms of each element do we have in the compound. Yes, it's very simple. If we get to know stock names, we will know in 90% of the cases the formula. Like in these cases, lithium, 2 lithiums and 1 oxygen, we just need to remember the I'm going to open the PowerPoint. We need to remember that the elements uh, of these two, let's say, the elements of these two columns are very simple. Okay, so for example, here lithium oxide, yes, we know that the oxidation number is 2 and the lithium is +1. Yeah, so we swift and we put the 2 here, the 1 here. We don't write the 1, so we will have lithium oxide. We don't say dilithium oxide. Why? Because lithium has always +1, and because it's an alkali, and this in the second column, that is earth alkali, they have oxidation number of 2, so it's always the same. Yeah, so sodium oxide will be the same, and sodium is not this sodium oxide. Potassium oxide, potassium, two more atoms and then an oxygen. Yes, so it will be always the same. Potassium oxide, rubidium oxide, cesium oxide, francium oxide, all of them with a 2. Yes, even though I'm not saying dilithium oxide is not correct, disodium oxide is not correct, potassium oxide is not correct, because if you only have one number possible as an oxidation number, you don't need to say, okay? So I hope you understood. Yes, like I said here, the lithium oxide, not the lithium oxide. Okay, cheers. Bye bye.